In this video, we're going to talk about derivatives of logarithmic and exponential functions. Our objectives will be to find derivatives involving logarithms and exponentials. We'll find higher order derivatives of functions involving logarithms and exponentials. We'll use the product, quotient, and chain rules to find derivatives of functions involving logarithms and exponentials. So let's just recall that we already talked about in our basic rules, the derivative with respect to x of e to the x is equal to e to the x. We'll be using that later. Now we're going to add to that the derivative of the inverse of e to the x, which is ln of x, is equal to 1 over x. And this is restricted to x values that are greater than 0, since the domain of ln of x is greater than 0. Remember, that's what your ln of x function is. It's more like this. That goes through 1, 0, has an asymptote here at x equals 0. Okay, so let's remember our log properties here for a second as well. ln of a times b is ln of a plus ln of b. ln of a over b is ln of a minus ln of b. Ln of x to the n is going to be n ln of x, like that. Let's make this a to be consistent, a to the n, like that. And let's see, anything else? That's good for now. So ln of 1 is going to be 0. ln of e is going to be 1. Those are some special things to know. Okay, so this can be written as ln of 4 plus ln of x. So y prime is going to be equal to the derivative with respect to x of ln of 4 plus the derivative with respect to x of ln of x, which is going to be 0 because that's a constant, plus 1 over x is 1 over x. It's easier than using the chain rule or anything like that. Get a simple version here with logs. That's what makes logs so great. Part B here didn't get on my blank notes, but B says y equals x ln of x, like that. So we are going to have to say u equals x, v equals ln of x, u prime is equal to 1, v prime is equal to 1 over x, y is equal to u times v, so y prime is going to be u prime v plus v prime u. Y prime is going to be 1 times ln of x plus 1 over x times x. Y prime is ln of x plus 1. And the derivative of b to the x now, the base is b, not e. So this is a different type of exponential function that has a base other than e. If b is greater than 0 and b is not equal to 1 for all x's, then the derivative of b to the x is equal to b to the x times ln of b, or ln of b times b to the x. Why is that? Let's figure that out for a second. So we can write b as b to the x as e to the ln of b, like that, to the x. And so that's going to be the same as e to the x ln of b, like that. That's the same thing. B to the x equals this. Remember, e and ln are inverses that undo one another. That would leave me with b raised to the x. When I raise a power to a power, I multiply the exponents. So u is going to be x ln of b here. Ln of b is a constant, so u prime is going to be ln of b. So the derivative with respect to x of b to the x is going to be e to the x ln of b e to the u times my du dx right here. Well, all of this is the same thing as b to the x, like that. And that's how we can establish or prove our rule. So let's go ahead now and find y prime, where b is equal to 3. Y prime is going to be 3 to the x times ln of 3. Be careful here with this one. We want to rewrite it as having just a 2 to the x if we can, like that. So pull that constant multiple of 2 out front. And our y prime is going to be 2 times the derivative with respect to x of 2 to the x. So that's going to be 2 ln of 2 times 2 to the x. Could also call that 2 to the x plus 1 times ln of 2. That works as well. Now let's think about this instead with the chain rule. If we want to extend the rule so far, if we have the derivative with respect to x of b to the u, that's going to be b to the u times ln of u times u prime. We have the chain rule. So we're going to have y prime is going to be, close your eyes and write it down, keep the same thing, times the natural log of the base times the derivative of the exponent, like so. So we're going to reorder that, ln of 2 over 3 times 2 to the x over 3. And that's your exact answer. We want to do that, give exact answers. Exact answers are required. Don't round. Don't stick things in your calculator. You need to give these expressions back exactly in terms of x. All right. If we want to take the derivative of a log with another base that's not a natural log, that rule is going to tell us that the log base b of x will be 1 over x times 1 over ln of b. This is the inverse function, so we're going to be dividing by ln of b instead of multiplying by ln of b here. And remember here with logs that x has to be greater than 0. So y prime here is going to be 1 over x ln of 2. And x has to be greater than 0 here. This is going to be 1 over 4x plus 1 times ln of 3 times the derivative of the inside is going to be 4. So there will be a 4 in the numerator there. We're going to have to use the chain rule. All right. Now we're going to find y prime for this quotient rule, where u is e to the x and v is 1 plus x, making u prime equal to e to the x and v prime equal to 1. This is u over v, so y prime is u prime v minus v prime u all over v squared is e to the x times 1 plus x minus 1 times e to the x is e to the x. over 1 plus x squared. Y prime is equal to e to the x times 1 plus x minus 1 over 1 plus x quantity squared. 1 minus 1 is 0, so this is x e to the x over, and I'm going to call this x plus 1 squared. I just like it better like that. All right. Now we're going to differentiate y equals secant theta tangent theta. And this is going to be a product rule. So u is equal to secant theta, v is equal to tangent theta, u prime is equal to secant theta, tangent theta, v prime is equal to secant squared theta. So this is u times v. Y prime is u prime v plus v prime u. U prime v. So that tangent times that tangent is a tangent squared plus v prime u is secant cubed. And we can factor if we want to say that this is a secant theta times a tangent squared theta plus a secant squared theta. What good might that do me? Probably nothing, but if I want to change everything into secants, 1 plus tangent squared is equal to secant squared. So tangent squared is secant squared minus 1. So secant squared minus 1 plus secant squared secant 2 secant squared minus 1. Something like that. Okay. So this is absolutely correct. I just would prefer to have it all in terms of one trig function if I can, instead of 2 trig functions. That's just a little simpler to me. Also, this looks better. It's more factored, and if I really wanted to get additional factors from here, I know how to do that. So let's go ahead now and find f prime of x when f of x is equal to -1 over x squared plus 1. Let's try this by making this a negative x squared plus 1 to the negative first power. So when we do that, f prime of x is equal to a -1 times a -1 is a +1. X squared plus 1 to the negative second times the derivative of the inside is 2x. So that's going to be 2x over x squared plus 1 squared. Let's try it with the quotient rule instead and just confirm our answer, even though quotient rule is unnecessary since we have a constant in the top. U is -1 and v is x squared plus 1. U prime is 0. V prime is 2x. So u prime v is 0 minus v prime u is a -2x over v squared is a +2x over x squared plus 1 squared. Right? 2 different ways to get the same answer. Just wanted you to see that. Now let's have a composition of functions here where we have to use the chain rule, sine, tangent, and then 2x. So we have an f of x, a g of x, and an h of x, let's say. Let's go ahead, though, and just practice our chain rule where we take the derivative of the outer function, leaving the inner function alone. times the derivative of the inner function. So the derivative of tangent is secant squared of its inner function times the derivative of the innermost function is 2. F prime of x is going to be 2 times secant squared of 2x times the cosine of tangent of 2x, like that. Right. Let's move on to the next one. We have u is equal to 4x e to the x, and v is equal to x squared plus 1. This is a quotient rule. This is u over v. U prime is going to be a product rule, so we've got 4x and e to the x, the derivative of the first part, leave the second part alone, plus the derivative of the second part, leaving the first part alone, like that. V prime is 2x. So we have u prime times v minus v prime times u all over v squared. It's going to give me, let's see if factor anything out here. 4 e to the x comes out of everything. Sits out here. This is 1 plus x squared plus 1 minus 2x squared over x squared plus 1 squared, 4 e to the x times x squared plus 1 plus x cubed plus x minus 2x squared over x squared plus 1 squared is 4 e to the x times x cubed minus x squared plus x plus 1 over x squared plus 1 squared. And then the next step to this would be to factor if possible. And I don't think we can factor this because we have our only rational roots are going to be 1 or -1. If we try -1 minus 1 is -2 plus 0, that's -2. If we try 1, this can be 1 minus 1 is 0, 1 plus 1 is 2. None of it gives me 0. So I can't find any rational roots there, and I don't know any other way to factor that off the top of my head. So let's go ahead and find the equation of the tangent line for the curve y is equal to 1 plus 2x raised to the 10th at the point 0, 1. We're going to use the power rule here with the chain rule. So this is going to be 10 times 1 plus 2x raised to the 9th times the derivative of the inside is 2. It's going to be 20 times 1 plus 2x to the 9th. Y prime at 0 is going to be 20 times 1 plus 0 to the 9th. It's 20 times 1 to the 9th is 20 times 1 is 20. So we have a slope and we have a point that's a y-intercept. y equals 20x plus 1 is my tangent line. We haven't talked about this yet, but since I have some space here, let's find something called the normal line. And the normal line is going to be perpendicular to the tangent line at the same point. So this is my normal, or this is my tangent line. There. My normal line is going to have a slope that's a negative reciprocal. So my normal line, my slope will be negative 1 over 20. My point is still going to be 0, 1, and that's still a y-intercept. So my normal line, if I call this one capital T of x for the tangent line, I'll call this one capital N of x for my normal line. And that's going to be negative 1 over 20x plus 1. Let me draw a little picture here for you if I can of what a normal line is. Let's just say, and I'm not saying that this is this particular curve, but if I have a curve like this, and I have a tangent line like so, at this point, then the normal line is perpendicular to that there. And that's going to be something that we care about in physics a whole lot. All right. So we've used the product rule today. We've used the quotient rule. We've used the chain rule. And so remember those, and also add the new rules up here for derivatives for ln of x and for b to the x and log base b of x to your library of derivatives that you have memorized. All right, that's it for this video. We will come back next time and we will talk about derivatives of inverse trigonometric functions. See you for the next video.